All right, everyone, it is now 3:30, which means it's time for us to get started. Welcome back to COM 426, Modern Web Programming. This is lecture 24. Before I continue with any of the announcements, I'll let everyone settle down. All right. And hopefully the mic volume has been adjusted correctly now. All right, great. So getting started here with some of our announcements. There we go. So again, as I mentioned last time, F'02, which is our first development sprint for the final project, is due next Tuesday, right before Thanksgiving break begins. So remember for this, all of the details regarding the expectations for the sprint, including the rubric, have all been posted on the website. So you can go and check and make sure ahead of time, right, what all of the requirements are, what is supposed to be submitted there. Including, for example, right, making significant progress and having these 3 features out of your 5 that you have written down deployed, right? That is part of the expectation there, as well as making sure that all of the team members are contributing. So you can see all of that on the website. We will also be, remember, having office hours all the way through then until Tuesday, and including Tuesday before break. So if you have any questions, definitely make sure to come to office hours and we would be happy to help you there. And again, as I noted, right, so it is due on Tuesday at 11:59. By the end of day Wednesday, you will have your grade and also feedback for the project from me. So if you have any, for example, if there's anything that I noticed that you may have to fix or any suggestions, that will all be provided to you in a timely manner so that you can continue on with the next part of the assignment. All right. Any questions about the final project so far? Great. Okay. And also the submission form for this will be on Gradescope, and that will be publicized probably tomorrow. So you'll have access to that. Make sure, again, that you have 1 submission. It'll be written in there, but make sure you have 1 submission per team so that everyone can be graded together at the same time. Okay. And then the second thing here, again, remember, as I mentioned last time, right, UNC teaching evaluations are now open. So it would be extremely helpful if you filled out the teaching evaluations for this class and also all of your classes, but definitely this class, right? If you want a course like this taught again, filling out the evaluation will be extremely helpful in making that happen. So this will be open until the end of the semester. And as I mentioned last time, if we get over a 80% response rate on the teaching evaluations, there may be extra credit added to everybody's total grade. So I think make sure to get that in. As we approach the due date for this, for the evaluations, also send out an announcement to keep track of our response rate as we go. All right. And then another announcement, which I think a lot of people will be excited about, is we will not be meeting here on Tuesday. So Tuesday, right, it is 3:30 to 4:45 p.m. class before Thanksgiving break. I am pretty aware that I'm sure a lot of people will want to use their free absence on that day and head out early or start traveling wherever you need to go. And in addition, right, the lecture date corresponds with the due date for Sprint 1, right? Sprint 1 is due Tuesday night. And so instead of lecture, I think it would be more beneficial for you all to be able to meet with your teams, continue working, right? During that time, 3:30 to 4:45, that is time that everybody should be free, right, to work on the project, because that is time that we are usually together. And so you can meet in some capacity, either in person or virtually, or however your team would like to do so. And I think that'll be good for you all to submit everything on time. And again, even though the lecture itself we will not meet, the office hours will still be available on Tuesday. So you're able to come and ask any questions if you would like. And again, I'll note here, I forgot to do it on this slide here, but as you saw for the idea submission and for the prototyping submission, right, the late days they do not apply toward final project deadlines. So these deadlines are, you make sure that you get it in by the time that is mentioned, okay? And then lastly, what we were planning on talking about was expanding on this idea of how do we structure our repositories, and also expanding on how can we use TypeScript beyond web applications and actually maybe go and develop mobile applications with TypeScript. And so I will be posting all of these materials to the website, including some example repositories. So if you're interested in still looking at that, all of the content will be available there. Any questions with this? All right, so we'll have this lecture and then there'll be one final meeting right on the last week of class on that Tuesday. Make sure you come to that because there'll be a lot of details there regarding final project and final project presentations. And then the last piece of kind of announcements that I have is this. So every single year at the end of the academic year, right, the department honors excellent TA and LAs in our department. One of the kind of unique and really, really special things about our department is the fact that we have such a large and healthy undergraduate TA kind of system and program. We have so many of your peers who help to contribute to all of the various classes that we have. And so, you know, these particular awards that we have are always really, they're a really special time to honor this commitment to each other and to our department, right? So we have awards at our department for spectacular graduate teaching assistants, right, every year, and we also have for two undergraduate teaching assistants or LAs. And so if you had any really, really good experience, for example, in our class with any of our team in TA or TA team for 426 or any other class, comp class that you're in, make sure to scan this QR code at some point by the end of the semester and fill out nominations for these awards. Okay, so it means a lot to the TAs, and it's always great to see all the great work that the community is doing. All right, so slide is here. You can scan this at any time, fill it at any time, and I think the department also sent out an email about this too. Any questions regarding any of this? Excellent. So we're going to then jump into the content that we're going to be talking about today. We're really going to kind of be rounding out all the things that we have been talking about for the entire semester and begin to kind of look at it at more of a top-level view, right? Looking down at all of the different pieces, all the different tools and technologies that we've introduced, and begin to think about this a little bit more holistically, right? So you probably heard this term before, and this lecture is titled, right, Building a Tech Stack. So what actually is a tech stack, right? So all a tech stack is just a combination of different tools and technologies, maybe frameworks, you know, programming languages, et cetera, that are put together to build a application. And so in 426, in this course, we have used a specific combination of these tools. Right? We have used Next.js, we have used React, right, for building our user interfaces. We've used Supabase for setting up our backends and having a database and authentication and various things. React Query, right, for loading data. If you remember, right, we started that in Pokedex. TRPC for kind of this API layer connecting our front end to the actual backend that we create. ShadCN, for example, as our design system, and many, many more. All right, so we have been introducing all of these pieces throughout the course and kind of layering them on top of each other. And using the combination of all these things, you are now able to create a full-scale, right, web application, for example, for your final project, which is the combination of all of these things. Remember that we talked a lot in this class about this idea of libraries and frameworks, right? So framework is like a toolbox. You have all these different pieces right inside of it. That's what we have been building, right? We have been building kind of our shed, our arsenal of all of our tools. And now that we have all of these and you understand how all of these things are used, you're able to build a full application with them. And so again, so far, right, you will, when you're working on your own projects in the future. In this course, we have given you a set of tools, which again are really, really great, and you'll be able to build many great things with them. However, when you're on your own in the future, working on your own projects, you will be needing to come up with yourself with kind of the combination of tools that should be used in order to create any sort of application that you want to build in the future. And in addition, right, companies as well. There's so many different companies, right? All these companies use a different combination of tools, and they use maybe things that you've never heard of, things with fancy names, other programming languages, right, et cetera. And so it's not just going to always be a Next.js application with Supabase and all these things, right? You'll be using a large variety of things to do so. And so what is important for you to be able to understand, leaving this class and going out there into the future, is not just, remember, right, these the specific tools that we use, but thinking about kind of what do these tools do? What are the overall kind of classification of all these tools? And in the future, if I wanted to build my own application, right, what are the different pieces that I need to add together in order to make something like that work? Right? How do we build this tech stack that we can then develop with? And so in this lecture, right, we're going to be building up the different parts of a tech stack to build a full stack application like we've been doing in this class and like you'll do in the future. Any questions so far here? Excellent. So what I want you to recall, this goes back, right, all the way to kind of our backend module where we talked a lot about all these different parts of our application, right? Recall that these applications, especially the ones that we have been building, typically consist, right, of 3 different layers. We start off with this kind of idea of our front end layer, or we often call this, right, the client side of our application. This is the code that is essentially dictating what the user is going to ultimately see, right? When they load the website in your browser, what are they going to be able to access and actually work with and use, right? So that is kind of the front end or the client side layer. And then on the other side here, we have the data layer. And the data layer is something that we introduced in the backend part of the course, where we really talked about, right, how do we keep, for example, persistent data? How do we keep all these different pieces of our app that manage a lot of the core functionality, right? So again, things like databases, object storage we talked about in our backend module. We talked about authentication, real time, all these other things, right? So that all sits kind of in this data layer. And then between the front end and the data layer, right, we have our third piece, which is our backend, or it's sometimes called the server layer. Right? This is code that's actually running on the server, where every time a user is requesting some website, remember, right, they make a request to a server. The code that sits here is the code that's actually running on that server, right? So it's essentially the bridge between the front end that we're building and the data layer that is powering our applications. So we can put a lot of things in here, right? Typically APIs, like you've been doing throughout the course, right? Remember in your Next.js project, you have that server folder, right? All of that is kind of what is being talked about here. Any questions about these three layers? At the core, remember, if you remember back from our last kind of lecture in the database section, or sorry, in our backend section, we referred to this as the 3-tier architecture. It's the same idea here. And so what actually, we know that we have the front end, the back end, and the data layer, but what are the pieces that actually sit in all of these layers, and how do these layers, right, connect with each other? We have been talking about different tools like Supabase and TRPC and Next.js, right? These are specific tools, but what are the ultimate categories of these tools? And so when you're building a tech stack, you'll often end up with something that looks like this, right? So instead of here writing out specific tools, I have kind of described classification, right, of tools. You can see here, all of these things correspond to something that we have used already in class. And it spans all 3 of these tiers in our architecture. All right. We start off all the way here on the left-hand side with this idea of kind of our web framework, right? So this is specifically targeting the client-side application, what the user sees, how do we describe the UI, and what the user directly interacts with. Right, so we have your web framework. And remember, we kind of talked about this in our Next.js section, right? But a framework is this entire package that we can use to build our applications. It includes things such as how do we describe and kind of render the UI on the screen? How can we manage routing, right? Switching between different pages. That's something that was very important that we talked about. And we also kind of have these 3 subsections in here that I've specifically mentioned. One of them is the UI library. Right? This is kind of how do we actually define the UI in our applications, right? How do we define our pages or specific elements, UI elements? We also have this idea of a styling library, right? So a lot of times we have some sort of tool that helps to essentially augment what pure basic CSS can do, making it easier for us to style our websites as a developer, right? Improving the developer experience overall. That's our styling library. And then finally, one thing that we have been talking about, right, in our design module is this idea of a design system. So kind of maybe a set of rules or a set of components, or maybe even more perhaps, like colors, layouts, etc. Right? A cohesive system that dictates how our application should actually be styled and how we can conform to those 4 key design principles that we talked about in class throughout that module. So this kind of is our entire web framework that defines, right, what our user ends up seeing. There's more though in this layer, right? So we have just these things, and this is really user-facing, right? What the user is actually ultimately seeing, it dictates that, but there's more. So another one here is this idea of a data fetching library, right? So we often need tools that help us to manage how do we actually load data in our applications, maybe deal with things like caching, because of course, sometimes, right, we don't want to just have to make repeated network requests. That can take time, it'd be expensive. So we might want to cache that data. So if we're using that data in multiple places, we don't have to make network requests, right, dozens and dozens of times for that data. So we might have some sort of tool that helps cache it and just make in general our various problems like race conditions and all the other problems you can have with fetching data, make it easier for us as developers. Another thing here that we end up running through a lot of times is this idea of data validation. So a lot of times, right, we're working with data in our applications, sometimes user-generated data, right? So the user is typing something, let's say, into a form. Or let's say, the user is, providing some information, or maybe we're getting some data from some external source. Well, we need to make sure that this data is shaped the way that we want it to be shaped. So for example, if we are asking a user, maybe this is a very kind of base example you've seen, right, with passwords a lot of times, right? Maybe a password is supposed to be a certain length, or maybe it's supposed to have a certain number of characters. We want to validate and make sure that what the user inputs is actually what we're expecting. Or, for example, you're fetching some data from an external library, like Pokemon data, as you all remember from kind of the Pokedex assignment. Maybe you have data about individual Pokemon species, and we want to make sure that the data that we're getting is shaped the way that we expect it and the way that we're using it in our applications. So if for whatever reason the Pokemon API updates and completely changes the way that the data is shaped, we're actually, right, we get an error on our side and we're told that this data is not matching the right format. And so we have used this particular library though, and I'll be racking your brains in a second on what this has been. You've seen it, except we haven't necessarily had a lecture on this particular part yet. But everything else, it's essentially, right, kind of this layer between the data fetching library and what comes next. So before I start moving into the backend layer, does anyone have any questions regarding the front part, the first layer of our tech stack? Excellent. All right. So moving on, right? So now we have developed this entire front-end application, but our front-end application oftentimes relies on some sort of data. It needs to communicate with the server, right? So either that is getting data, maybe that is updating, right? Mutating data that we have stored in our database, for example. We need a way to communicate between the front end and the back end. And that is what this box here is describing. And you can see that this box, right, is serving, it is a bridge between these two pieces, the front end and the back end of our application. This is what is actually defining, for example, our APIs that we're working with, or how we end up interacting with the server. Right? So it is something that you'll see, right? We use maybe on the front end, we access on the front end, but we also define it maybe from the back end. So this is a bridge of how we communicate between these two pieces. And then once we're in the back end, right? So we're communicating, the front end is now talking to our back end. We then I have a little orange bar here, and that orange bar is actually the same thing here that we have already noted is data validation. Whoops. So sometimes we have validation that happens on the front end, but then we also have some sort of data validation here on the back end. And so sometimes you see that. So we've added a small little bar here because you may encounter this at some point, particularly because as we're talking between our API and maybe our database, for example, we want to make sure the same type of data concerns that we had are addressed and that things are formatted in the correct way. All right. And then going up here, we have the ORM. So this is something, right, we did talk about, and we spent a lot of time on this. You all did the reading, right, for Drizzle, and you've been using this all this time for Oriole, Alias, and you'll be using it for the final projects as well. And what ORMs help us to do is actually communicate with our database. Right, so we have some sort of server here. Our server needs to communicate with the database to get data or to mutate data, etc. And a lot of times we also define, right, maybe our schema. What do our tables actually look like? How should our data be structured? That is also done, right, in the ORM. So a lot of you who have been working, right, on, for example, setting up your backends and your databases in your final projects, you've been using the ORM to do this, right? Specify what tables should be in our database, and then you push that schema up, and it's then all that's in your database, right? And then another thing here I've noted is this idea of the data layer client, right? So sometimes we have other services, right, like object storage, uploading, downloading images, or authentication, where we have some other external package that helps us do those things. And so that's why we kind of have this dotted line around it, because sometimes we use this, other times we don't, etc. Any questions here in our backend layer? All right. I don't have colors for the data layer, but we have the data layer, which is the last thing here in our diagram. And this is actually, right, some other server. It might be something that we own. It might be something that another service, right, like Supabase provides for us. This is where our actual data is stored and persisted. So things like our actual Postgres database, cloud object storage for uploading files, maybe authentication is here. We might say like real-time or AI features are also placed here, etc. Right? So these are all kind of different parts of this data layer. And we use these things like our ORM and the data layer client to actually communicate with our data layer. Right? So these are kind of these arrows here that we have between the ORM and the database and the data layer, and for example, the data layer client and the object storage. Any questions with this particular diagram here so far? Excellent, right? So this particular diagram is a much more abstracted version of the type of tech stack that we have been working with. Right? So the applications that you build follow the same structure. It has all of these tools in it. However, instead of just name dropping tools, right, we actually can now think about what are these tools, what role do they play in building our full applications. And so what I now would like you to do is to think about, okay, we have this particular diagram here. We have all these pieces that supposedly build our tech stack. Let's relate this now directly with what we have been doing in this class and what you're using in your final projects. And so we have some diagrams here that the TAs are going to help hand out. And we'll spend a few minutes on this. What I'd like you to do is we essentially have a blank version of this diagram like this. And you will fill in these different pieces using kind of the tools that we have learned. And I'll say that all of these boxes in here can be filled out. And so I'd like you to think through this for 5 to 7-ish minutes, and then we'll come back and kind of go over this together. All right, everyone. So we had good, I think, extremely good discussion on this. And I think that this is a good way to kind of contextualize a lot of the different pieces of the stack that we have been working with. And so knowing all of these things now, I would like to kind of talk with you all. We'll build this up together, our full diagram here. We're going to go one at a time. So I'll say one thing, I'll ask for a volunteer, and then you'll tell me what it is. And we'll fill out this entire table. And so again, as I will know, because some people are asking, so all of these things, all these boxes can be filled out, maybe with the exception of this one. But even that one technically can, I think, based on the way that we've set things up, can be filled out. So we'll get started with our web framework, which is the first one. And this may be a bit of an easier question compared to some of the other ones, because we've been using this a lot. But any volunteers for that? Oh, nope. Yes. Close. So React is part of it. React is part of it, but the overall framework, yeah. Next.js, exactly, right? So React, yes, React is kind of the main thing that we use to build our user interfaces, but our web framework here would be Next. So I'll write this in. All right, everyone, next. So UI library. Any volunteers? Yes. React, yes. So very close there, right? React is a very big part, is how we've been building all of our pages, but it is kind of within, right? We use React within Next.js. So React here. React. All right, and then styling library. Yes. Tailwind, exactly. Yep, so we have Tailwind here. Right, so we use Tailwind instead of CSS. Tailwind augments CSS functionality, makes it easier for us to kind of style our components. And then design system. Anyone for design system? Yeah. ShadCN, exactly. Yep. So we've been using ShadCN, right? And ShadCN components. Remember, our design system is what specifies, right, kind of our design language, what things and different components might look like. So good. So ShadCN. Excellent. We choose a color that's going to work with this. I think, yeah, we'll do this one. Data fetching library. Next, any thoughts? Yes. React query, yes. So remember, right, our data fetching library, if we go back, and I know that some of these now may be a bit harder, so I'll reload. Remember, right, helping us load data from, for example, external APIs, managing caching and optimistic updating, all these different things. Yes, it would be React query. So React query right here, amazing. I think the hardest one now of all of them, data validation library. Anyone recognize or remember this one? Yes, all the way. Zod, exactly. This is something that we have been using, except, again, this may have been easy to miss because Zod is something that maybe, especially if you're working on the final project, you have been defining these. And I'm actually going to take a little bit of a very short detour here to kind of to very briefly talk about this. Right, so remember in your TRPC code, so I'm going to go here to, I'm just going to, I don't want to put let's put GitHub here and jump to the final project. Actually, we'll do the A06, I think, template. This should be good. All right, let's get this on. There we go. So this is kind of your, this is like your starter code for alias. I'm going to kind of just hide, I have my text on here. I don't want to delete it immediately. All right, so in your server folder, if you remember going into your API folder here, and let's say routes, and let me just choose one like messages, right? So this was kind of our API endpoint for actually defining, thank you, defining our endpoints for actually, right, loading data. And if you remember in here, we have these two lines in a lot of our API calls for kind of the input and output types. And so we put in here a specific type object or a data validation object, which is basically saying that, for example, any input into this particular API, it should match the shape of that particular object, paginated messages request, and my output should be an array of messages, right? And you'll notice here that, for example, with messages.array, this is not direct kind of TypeScript syntax, right? Because otherwise you'd have like messages and then you have, right, two brackets to indicate that it's a list. This is slightly different. And that's because if we look at something like this, right? So we kind of click here on messages, you'll see that messages is imported from here, this particular folder, server, models, and then responses. So I'm going to jump over to that folder. So server, models, responses. And you'll notice now that we have all of these objects that we have defined. This is not defining, like we're not just defining a type or an interface, right? We actually create an object, right? Export const, for example, server equals z.object. And we add all these different things in here. So for example, a server should be should have a string ID, a string name, a nullable string server image, etc. And all of these things, including this kind of magical Z that's in our code here, comes from Zod. And so what Zod does is it creates an object, for example, like a channel object or a server object. And whenever you want to parse, right, you use like the model, for example, .parse, where you have like server.parse and then you pass in some object. And Zod will go through all of these particular fields and make sure that they match exactly to the specification that we have defined here. And the cool thing by using Zod and using data validation objects rather than just types is that we can actually specify even more validation than just types. So for example, if you wanted to specify that the name should be less than 10 characters, there are actually functions, or there's kind of, in addition to just .string, you can actually specify, for example, the length of the string, or a range for a date, or a range for numbers, etc., using Zod. And so if I kind of pull up here Zod documentation, right, you can see here Zod, right, is a data validation library, and I can go to like basic usage, and let me see if there's an example where they have a nice, let's see, defining schemas. They probably have some examples, right? So this is maybe how, right, you create some sort of object and then you end up parsing that and it will turn it into and make sure that it's all valid. There's various other things though, and I want to see if I can find one of them. This is actually probably a good one, right? So like email. So you can specify that a specific field, rather than just being a string, it is an actual email. And you can put, for example, a specific regex pattern. So regular expressions, if you took right for 55, you can put a pattern in here, and it's actually going to make sure that the text that was inputted matches that pattern. And if it doesn't, it will actually error out. And so this is a really, really useful library because there's a lot of different times where you want to be more specific about types or about inputs than just what type it is, right? Because we can have a lot of things that are strings, except we want to maybe make sure that we have different validation, right? Here's numbers. So I can specify that a number should be greater than 5 or less than 5 or positive or negative, etc. And so there's extra kind of validation that can be done on top of just data types. Any questions there? All right, so again, you've used Zod. There are a few people I think who had the name recognition. Maybe some of you had to look in your code for that, because again, this is maybe the least familiar out of all the things in terms of direct name recognition, but it is a very important part of our stack. Great. API layer. Anyone? Yeah. Exactly, TRPC. So TRPC is what we used, right, to define our APIs. So TRPC, as well as access our APIs from the front end. So perfect, we have TRPC there. Now I'm going to jump to ORM. Anyone for ORM? Yeah? Drizzle, exactly, right? So Drizzle we've used. So Drizzle. Amazing. And then let's do this section here first, this data layer. So data layer, database. What do we use to set up our database? Yeah. Supabase, exactly. Yep, if you put Postgres here, that's also fine because it's a Postgres database. But yeah, our database is ultimately sitting on a Supabase server. So we can say Supabase DB. And then object storage. What do we use for object storage? Yeah. Okay, no worries. Anyone, yeah. Yes, more Supabase. And exactly, I think you're saying buckets, right? Yes, it is true, right? We put it in Supabase object storage buckets. So perfect. You all were right with that one. So Supabase, right? Supabase storage, it's put in buckets in the server. Great. Auth, what do we use for auth? Supabase, exactly. We had, right? So you'll notice here that in our data layer, pretty much everything was Supabase because we use what we call a backend as a service, right? It handled all these things for us. So Supabase. Now, if I were to have, for example, like an AI box for an AI model, maybe you would have said, OpenAI or Gemini or whatever is used. And then finally, data layer client. Any thoughts on this one? I think this and Zod were the two that had the most amount of questions when we were walking around. So anyone get there? Let's see. Yes. Also Supabase. Yes. So this is the thing that you may be forgetting here, right? So Supabase is a platform, and we have all these different parts in our data layer that's our platform. But then we also have Supabase as a JavaScript library that we import. And then, for example, we did await supabase.auth.signin or supabase dot I think storage.upload or download or supabase.realtime, right? So we're using the Supabase JavaScript libraries. This is called like Supabase.js, right? So Supabase.js. And that allows us to communicate between our backend and, for example, object storage, auth, and real time, just like that. So perfect. There you go. So these are all of the different tools that you've used, right? You've gotten very good at using these, and you've been doing them in projects. In your final project, you've been using them, right? But ultimately, all these tools, they fit into the greater, right, kind of puzzle that is our overall tech stack. And it is very important to know what these pieces are, because if you're developing your own stack, well, all of these things are technically interchangeable. Right? So for example, if I didn't want to use Drizzle as my ORM and I wanted to use something called Prisma instead, which is another ORM, I can just swap that out and everything will still work, right? I can just use Prisma instead. But by knowing these different categories, it becomes very easy then to kind of conceptualize that as you're building up your stack, if I were to delete Drizzle and I wanted to replace it, what does Drizzle actually do? Where does it fit in? And what are the other tools that may fit in the exact same category that kind of defines what it does? So great, yeah, this is all correct here. Again, so when everyone is heading out at the end of class, you can hand that in. And I also have here the answer key, which is basically what we have here. And I accidentally left data layer client missing on my model. Great. So wait, again, this is our stack that we've used. We've used things like Next.js, but again, everything that is in here, we can completely substitute it for something else, and we can still build an app with it. So if any of you were in Comp 423 or 590 with Chris Jordan, right, you built a full web application in the end, but it was using a completely different set of tools, which if you're in that class, you can see is here. Right? So for example, instead of Next.js, you use Angular. Instead of Tailwind, you use something called SAS or SACSS, or sorry, SASS, right? It might be SCSS. That's the file extension. Anyway, right? You used Angular Material as your design system. And in fact, in that class, your backend was in an entirely different language. It was in Python, not TypeScript, right? So you use Fast API for your API layer, use Pydantic as your data validation library, SQL Alchemy for your ORM, and then ultimately your database was actually put in UNC's cloud, and you had UNC authentication all hooked up, right? So again, completely different stack, but you notice how this diagram still fills out. We still needed all these tools. We just used a different combination of tools to build our application. Yeah. Yes. Yeah, exactly. So if you looked any of these things up, like data validation library, data fetching library, design system, it would be, yes, this following industry standards. Perfect. So again, right, creating a stack, right? So you've been exposed to many different tools and technologies. And again, the entire idea here is that you can mix and match tools. And as you become a more seasoned developer, you'll begin to get a better sense of what tools are, good to go together, what can make a nice stack to work with. And honestly, this is one of the more fun parts of developing, is learning about these tools, trying new things out. Because again, there are a lot of developers also like you who might be working on something like Next.js, or they're working on a database, and they're like, this is all great, but I don't really like this. I want to make my own library or my own framework. And so there are many tools. A lot of these things are just developed, like what's in our diagram here, back here, right? Were developed because some developer out there said that, all right, the existing tool I have, it fits this use case, but it's not that good. I'm going to make another one. That's how React Query came out. In fact, that developer, I believe his name is Tanner, maybe Tanzer Lindsay or something like that. He is the one who developed React Query, and he is also currently developing a new a web framework called TanStack Start, which is using a whole bunch of different tools. And he is developing it because he's looking at Next.js and thinks this can be done better. I'm going to try to make it better. Right? And so he's actually, right, he's the creator of React Query and so many other frameworks. He is spending a lot of his time working on this framework and is currently in, I believe, in alpha. And so maybe a few years down the line, if this course is taught again, maybe it will be using TanStack Start instead of Next.js, right? But again, the core concepts are still the same. Even though we might be using entirely different tools, all of the concepts that we have been developing still apply across all of these tools. Questions here. Excellent. So with the remaining time, we are going to also kind of survey a few other tools. So I mentioned one, right? Angular with the Excel tech stack and also this TanStack Start. But there's many web frameworks out there. But I want you to pay attention to actually how, even though these are different things you've probably not heard of, there are a lot of similarities between what you are familiar with and maybe these other tools as well. Right, so again, so far we have been using React and Next.js, but as we've been talking about, there are many other tools, and we can replace these tools with other things and still build web applications. Right, so Angular, for example, is a web framework that I'm sure if you've used it, right, you've had some experience. This is actually made by Google. So React is technically managed by Meta. Next.js is managed by Vercel. Angular is managed by Google. Originally, actually, Angular is older than React. So AngularJS came out, you can see in 2010. It's 3 years older than React. And it was rewritten. So AngularJS became Angular. It adopted TypeScript and all that stuff in 2016. And so Angular is a full framework. So when I say framework, right, I'm talking about web framework, you know based on the diagram that it is analogous to Next.js, right? Not necessarily just React, but Next.js, right? It's a full framework. It handles everything like routing, etc. And so just like React, Angular breaks UI into components. We use components as our building block of our UI. We build these components by combining HTML, CSS, and TypeScript. There's various syntactic sugar things that are added to augment standard HTML. So in Angular, you have these things called directives, where you can have like if statements and for loops within your template. So I have a little link here. I'll open real quick. This is not pointing to where I wanted it to go. Let's see if there's a control flow. Yeah, there you go. That also. I wanted to see an actual, okay, maybe this is a better example because it's actual HTML in here, right? You could see maybe like in React, right? You used list.map to iterate over items and kind of display a list. In Angular, you can use an actual for loop using @for, etc. And so these directives help us to specify and kind of build up our UIs. Now, something that's interesting to note is that Angular components are actually defined using classes. So in React, we use functions, right, to define our components. In Angular, you end up using classes. And there is state management, except instead of calling it a state, they call it a signal. So you have the signals, a very similar idea to states. And you can see this is what an example of an Angular component might look like. So you have a class instead of a function, right? You have some decorator at the top, which you probably have heard of, right, from 301 @component. And then we have links to an HTML file and a CSS file, right? So in Angular, instead of just having everything in one nice file, like a .tsx file, we have 3 different files that ultimately together make a component. And so here is a side-by-side, right? What Angular would look like on the left-hand side, and then React on the right-hand side. And so you can see, same thing. They do the same thing where you have a counter and you have a button that increments the counter and you display the counter. And so you can see the difference, right? So this is a separate file. We use our I think this should say the my state. I think that should be renamed. So if it says my state up there, that should say counter. So I will kind of note, right? This would say counter here, counter. And then you have a button that updates the state in a very similar way to how you had a set count function. Questions? All right. So again, different ways of doing it, but ultimately, Two entirely different frameworks can do the same thing, as you see. Another note here, which is interesting, is that Angular is a SPA application by default. It does not use SSR. So that is one optimization that Next.js has that Angular hasn't. However, recently Angular has been in beta and various updates trying to integrate SSR because of how useful it is, again, for all the reasons we talked about. And so you can see here, it is an experimental phase. You can see server rendering, all this kind of stuff they're working on. All right, let's keep going because we have a few more I want to show here. Another one is Vue. If you have heard of Vue, so there's one former student of this class who is messaging me. She's with Chris Jordan in Study Abroad, and she's mentioning that she's using Vue right now in her everyday work. And so Vue again is another popular framework for building interfaces. And this is actually developed by a developer you can see here, Evan. He's actually the one who made Vite as well. So again, there's all these engineers out there who are developing these things, which is pretty cool to know. And you can be one of them in the future if you would like. Right? So Vue is open source. However, Vue is a UI framework or a UI library. So it's more kind of analogous to React rather than to Next.js. So it's made for building user interfaces. You organize components in a special .vue file, and you have everything like your CSS, your HTML, and your logic all together. Vue handles states using something called refs, and watch handles side effects. Right, so again, like we've been saying, you'll notice that even another framework, we have the same type of problems that we need to solve, like state management, right, side effects, all these things. And there's a special way to do them in each of these frameworks. Here's an example of what Vue code looks like. You can see here that we have 3 different parts. So again, right, completely maybe foreign way of looking at it, where you have a separate script section and then a separate template section, which is our UI, and then a separate style section like so. Again, though, this does the same thing. We have a ref, which is essentially like our state. We have a function where we can do like counter.value and then increment it, and that works. And you can see, again, side by side between React and Vue, what this would look like. All right. And you can always feel free to look more closely in this on our slides as well. There's something called Nuxt.js, which I think is fascinating. I was searching the longest time when I was looking at this because I could have sworn that Nuxt was created by the same people that created Next because it sounds exactly the same. But no, these are different projects. But since Vue, right, is just a UI library, you have a larger framework that handles everything else, like SSR and like what is it, routing, right? So you can see here, there's Nuxt.js, which is a fully featured framework. You can see there's all these docs here, right? There's like SEO, state management, views, routing. I'm sure is somewhere in here. There it is, routing, right? So you can see here that routers, right? It uses its own, maybe this might be file-based routing as well. Sorry, I know their website is pretty dark. Let me see if I can, there we go. So you can see that here. Right, so again, though, right, we have a framework, but remember, this framework has the same type of things that Next has. It has SSR, it has routing, right? Even though we're using a completely different framework, the core kind of problems that we needed to solve, like state management and routing and for example, SEO with server-side rendering, all these things are still problems that have to be solved in any framework, and so we have a potential solution here. There's one more in the front end side to mention. It's called Svelte, and I believe, and I hope I'm not wrong on this. I believe, from what I remember, if any of you are related to Comp 110, Trailhead is built, I believe, using Svelte, if I remember correctly. So Trailhead is kind of this learning platform, right, for Python for 110 students. It's built with Svelte, again, if I remember correctly. Right, Svelte is another UI framework. You can see this one was released in 2016. Like Vue and React, it's just a UI framework, so it is not necessarily a full web framework. The wording here, if I wrote UI library, it might have been better to use, but that's what it does. Svelte has a very high developer satisfaction rate. According to our last year's developer survey by Stack Overflow, right, 73% of developers who you ended up using it wanted to keep using it. So it's one of the more popular and loved frameworks in the community. And here's some technical details, but Svelte actually modifies the DOM directly. So there's kind of this layer, if you read in the React reading, there's something called the virtual DOM, and React has kind of a separate DOM tree that it performs operations on, and then it kind of commits, right, the changes and then changes the DOM. To re-render, for example, Svelte just modifies it directly, and it actually ends up leading to slightly better performance. It may introduce some problems that, as a developer, you have to be aware of. But remember, that's the entire point, right, of engineering. There's different ways to solve a problem. There's different trade-offs that people choose. And so the developers of Svelte decided, let's just modify the DOM. Let's not manage some virtual DOM. Again, trade-offs, maybe better performance, but you might introduce some issues in other places, right? That's just the nature of development. And also another design decision with Svelte is that there's no such thing as basically every variable is a state variable. So just by defining a variable, if you mutate it, it's just going to re-render, right, directly. And so you don't have to have this difference between state variables and regular variables. It's all, any change just mutates, right? So here's some example code, separates your 3 different parts, right? Your HTML, CSS, and functionality with TypeScript, kind of in a similar way that Vue did. So we have style, and then main, and then we have a script. But you'll notice that we don't have any state variable, right? So we essentially just have a variable here, counter, and then when we increment counter, we don't use any sort of like creating a state and then a state mutator function. None of that happens. We just use it directly, and that is Svelte's approach. And so again, side by side, you can see the same component in Svelte and in React. All right. Wonderful. And then there is something called SvelteKit, which is the full framework that has routing, server-side rendering, everything, right? So again, like we've been talking about, right, we have React, and then we have, right, which is our library, and then we have a framework Next.js. Or we have a library Vue, and then we have the framework Nuxt. We have a UI library Svelte, and then we have SvelteKit, which is our full framework. As you can click on this, right, there's some details here about SvelteKit. There's like there's an interactive tutorial. They even have a Discord chat room, I guess, for answering any questions people have. All right. I ran through that very fast because, again, with our interest in time. But what I hope that you were able to get out of this particular part is the idea that even though there are so many web frameworks out there, there's so many ways to design our UI, set up routing, all this kind of stuff, right? Our front end of our app. There's some key concepts that stick out, which is used across all of them. This idea, right, of composable UI with components, right? Angular has this idea of components, Vue does, React does. They all have, right, this idea of composing our UI and making UI composable. State management and kind of re-rendering our UI when some sort of variable changes, right? Remember, again, back in your one of your first assignments, which was your pixel art maker, right? You had to manually write all this DOM manipulation code. So whenever someone like pressed a tile, it would change the color, and all that would have to be done manually. All of these frameworks have some sort of automatic re-rendering when a state changes. So you can see here some, right, use stated in Next, signal in Angular, ref in Vue. Side effects and things like data loading. So we have use effect in React, effect in Angular, and then watch in Vue, right? So we have the same type of problem here with managing side effects. Then we have different ways of doing it in these different frameworks. And then architectural concerns. So routing, SPAs versus MPAs versus SSR, right? That's the reason why I know it was maybe painful to go through that exercise of learning it, but it's so important to learn it because it helps you really figure out how these frameworks actually work. And when you're trying to choose one, you can now look at the architecture and be able to say, oh, this one has, right, SSR. That's good for SEO. Maybe I should use this, right? That's why it's important to talk about. And so again, one of the key design goals of this course that we talked about in the beginning is that we want people to be able to gain not only just familiarity with specific tools, right? You all can now make Next apps and use React, which is great, but also learning the fundamentals underneath that. So if you were to go into another context, working on another project, another stack, you'll be able to notice these patterns and you'll be able to pick up these new things much more quickly. All right, any questions before I go over just a few more things for the last 5 more minutes here? Yeah. Yes, so in that case, right, but in the end, we're still kind of, our UI is still reacting to some value changing, right? So even with Svelte, right, if we had a counter, we mutate the variable, our UI does change to reflect it. We don't have to kind of manually settle it up. Svelte just kind of takes it and says, you know what, there's no differentiation. Basically, everything is a state, and every time you change a value, it's just going to re-render. That's essentially Svelte's. Yep. And then backend services, right? So again, we've used Supabase for everything. In the real world, you might not use Supabase. You might use other things. And it's important to note that there are so many services out there that, and not even, you can also just, if you want to set this up all manually too, you can do so using a server. Right? So again, databases, there are so many different database providers that we can use. We have Supabase, but there's also other popular ones. So like Neon, for example, that's an open source Postgres provider. It is a pretty good free tier. A lot of people use it for personal projects, and it is a Postgres database. And so just like how you connect your ORM to Supabase using a database URL, you can connect your Drizzle ORM to a database in Neon with a database URL. Right? These are interchangeable things. There's also something called PlanetScale, which is a MySQL. So instead of a PostgreSQL, it's MySQL database. It's a different type of database, but it is a very, very popular one. It's extremely performant. If you're building a really, really kind of huge application, right, used by millions of people. So like even services like Cash App, like MyFitnessPal and other things use, I think Etsy uses PlanetScale as their database, right? And there's many others. Vercel, I think, now has their own database. Prisma has its own database. There's so many different database providers out there, right? But it's, again, important to know that you can use any of them, and you should look and compare, right? What are the trade-offs between these different databases? But ultimately, you can still connect to all of them using an ORM and your stack, right? These are all interchangeable things again. And you can also self-host your own database. So if you were in, for example, Comp 590 with Chris Jordan or 423, you actually went in, there were some instructions where you use Carolina Cloud Apps. So Carolina Cloud Apps is essentially a server that UNC manages, ITS manages, and you could go in and actually spin up your own database inside of UNC server. So instead of using like Supabase to manage your server, you actually set up your own database on your UNC server, and then you connect it to it. So you can, if you owned a server or had access to something like Cloud Apps, you can set up your own database. It's called self-hosting, right? This is a term that's used a lot in industry. The idea that, well, I want to just set my own backend up. I will manage it myself. And so that's this self-hosting idea. It may cost some money, right? To actually set up a server is not necessarily cheap. But if you're lucky, for example, if you're a UNC student, you get a free server that you can technically access as a student, right? Authentication as well, right? So Supabase we've used for authentication. You can technically do your own authentication, right? We kind of touched on this idea of signing, right? JWTs, right? We talked about this symmetric encryption, or sorry, this signature signing with, for example, right, this secret, and you used, right, you generated a signature. We had that demo in class. The TAs were here, right, and we were kind of demonstrating what that would look like, right, signing and verifying signatures. You can do all this manually if you want, and then it would actually cost you not really anything because you can do your own authentication. But other things such as all these other auth providers, right? If you want, sign in with Google, sign in with GitHub, sign in with Microsoft, all these different things. Sometimes using another provider is helpful to do that. And so here are some others that you can always take a look at in your own time, right? NextAuth, Clerk. There's other ones too, like Google I know has one that you could potentially use for your own authentication. And so all this does is it keeps track of your users. It gives your users, right, some sort of token to identify some user ID. And then you can use that user's user ID placed in cookies to determine who they are. So the same type of thing that you can do with Supabase auth, you can do with any other auth provider. All right. And then I also have here a note on real-time is actually trickier because real-time, in order for real-time to work well, it actually needs to really integrate with your database and with other things, right? Because you can't just set up your own real-time if you're using like some external database, because your database needs to essentially notify the real-time service whenever some maybe change happens in a table. And so it's harder to set it up. You can, though. There's other things like Socket.io to set up WebSockets and real-time. You can set up your own real-time server if you're kind of self-hosting everything. And that's why Supabase is quite nice, because it has a real-time feature integrated into it. But that's kind of a note here. You can look at this. But it depends really on your use case. And so there's a lot of research. If you do want really good real-time functionality, more research might have to be done to deal with that. And then finally here, we have deployment. So we've been using Vercel as our cloud deployment platform, right? However, there's many others. We kind of talked about this within our lecture on Tuesday, right? Like Netlify, GitHub Pages. There's all these different ways that we can get your app deployed. Carolina Cloud Apps, right? You can throw your app into a server and host it that way as well. This idea of getting your app actually loaded on the internet. Are there any questions with any of the backend, any of these backend things here? All right, everyone. Again, you can see here, as I mentioned, there's so many different tools. You can use various tools to make a different site. And so if you have any questions on any of these, you can let me know. Otherwise, I hope you have a great Thanksgiving break. And if you have any questions, make sure to come to office hours and we'll help you.